As I promised, every week I would appear before you and I will try to get you something new which is happening in the world, so that you don't feel left out on what is happening. And it's going to help you probably have regular kind of conversations with your friends. All right. So friends, let's understand something which is happening in the space of quantum computing. So as part of quantum computing, there has been approximately 6,000 crore which is invested as part of National Quantum Mission. Okay, this is part one. Part two is in Amravati, already Quantum Valley is established, right? It's open sovereign quantum infrastructure. Why? Right? Why is a country and across the globe people investing so much of money on quantum computing? Just a moment. So there is a lot of investment going on in the space of quantum computing. IISc Bengaluru, IIT Bombay, IIT Delhi, IIT Madras, and everybody is investing heavily in the space of quantum computing. Okay. And even in the space of cyber security, with the advent of more and more data coming in, and with the advent of more and more AI systems being built, security is to some extent getting compromised, especially in the space of banking, defense, telecom, etc. So quantum computing is what people are looking towards in order to identify the threats early. Okay, and that is very, very much needed, especially at a national level, right? Because if someone is going to hack into the government systems, then it's going to be a big disaster. Okay. Hence, not just in India, across the globe, and all the tech companies are spending a lot of money on quantum computing. But what is this quantum computing in the first place, and how does it work in the space of machine learning? And that is exactly what we are going to talk about. So the first thing is this. Now let me close this. Yes. Hope you are able to see the screen. So AI in quantum computing, let's understand using regular machine learning algorithm and using the quantum way also. And let's try to understand whether the regular way of building the models on regular computers, normal computers, is that a good thing? Or doing the same task using quantum way, is that a good thing? That is what we will try to understand. But at this point, you might be thinking that if regular way works well, if I'm going to run a machine learning algorithm and build a model, if that is going to work well, then why do we even need, okay, then why do we even need the quantum computing? Okay. So we will try to look at how to build the machine learning model using the regular ways. And then we'll try to compare it with the quantum ways and then do quick comparison. We don't need to get into too much of physics or too much of math at this juncture. Even the coding part, you need not worry because it can be generated using prompts, the way we have seen yesterday. So I'll just run this. Okay, I'm using anti-gravity from Google. That is just an IDE. IDE means integrated development environment where you can just write the code. That's it. Okay, you can just write the code and job that. All right. So that's all we do. Vibes person again joined. Okay. So we just install some library. Don't worry too much about that. Now let's get into the problem. We will take a very tiny business problem, which is if you take the measurements of a tumor in your body, okay, how does how is a tumor taken? They insert a needle and they take only the needle portion tumor. Only the needle portion tumor they take. And then they take all the measurements of the tumor in the lab. And then they predict whether it is benign or malignant. Benign means non-cancerous, malignant means cancerous. Okay, simple. So if we were to, this is a classic data set which is used in a lot of machine learning trainings. Okay, in a lot of machine learning trainings, there's a classic data set which is used, right? And each tumor has several measurements. And to keep things simple, okay, you think about this, right? People look at how large the tumor is, how irregular its shape is, and then they decide whether it is good or bad. Good or bad in the sense whether it is non-cancerous or cancerous. Okay. Now, the job of the model is to learn the patterns in the data, right? Any machine learning algorithm, what does it do? It will learn the patterns in the data. So what we are doing is we are just loading this breast cancer data set, which is publicly available using this code. Don't worry about the code. You can automatically generate it using your prompts also. All we are doing is we are loading a data set. We are taking two features. One is radius and concave points. Then we will just visualize it. Okay. Then we will also split the data into training and test. And then we'll build the model. So let me run it first. This is how the data is. All these blue points are tumors of the patients who have benign, tumor, meaning non-cancerous. All these red data points that you're seeing are malignant, meaning cancerous, tumors in the patients. Okay. So by just doing a plot, we are able to figure out, how the tumor size would be and how the shape irregularity would be. Depending on that, there is a segregation that these are the tumors which are benign and these are the tumors or these are the patients who have malignant tumor. Okay. This is a very, very simple way. Now, what is quantum? First of all, even before we get into quantum computing, we'll get there. A regular computer, it will store your data in bits. Whatever, documents or PDF documents, your resume, your images, whatever you save on the computer, it is saved in bit format. That means zeros or ones. Whereas a quantum computer uses qubit. It uses something called as qubit, which can be a mix of 0 and 1 at the same time. Okay. Zeros and ones are mixed. That mix is called superposition. Okay, that concept is called as superposition. So if you take one qubit and if you try to mix it and look at it 1,000 times, 50% of times it should show 0, 50% of the times it should show 1. But in short, friends, if that is confusing, this idea itself is confusing about quantum computing, then please remember one thing. The regular computers store the data in bits, 0, 1. But quantum computers store in a concept called as qubit, right? Which can be a mix of zeros and 1 at the same time. Same data, it is saved in 2 different ways. If we were to run this code, okay, then this is getting saved. I'll go to this and run it. Just bear with me for a moment. Now, let's go back to the regular way. What we have done here is we have loaded the data, that is a breast cancer data set. And our job is to build a machine learning algorithm which will classify a tumor as benign or malignant. This is what we want to do. Okay, this is what we want to do. Now, if we were to complete that machine learning algorithm, what happens? So let me run it. How much time did it take to complete the training? 0.09 seconds. In 0.09 seconds, a machine learning model was trained. Means under 1 second. That's how fast it is. Now, if we were to publish the accuracy results, how accurate the model is? 96.5%. Okay, 96.1%. No, sorry, 5%. Then, if you load the model that you built, if you call that model, and if you were to do the prediction for new patients, immediately you're getting the result. Immediately, we get to see the result that it is malignant, right? This is a complete workflow of the regular way, the traditional way of building algorithms. Now we have something called as quantum way. Quantum computing. We'll take the same tumor problem. The moment there is tumor details, you should classify whether that tumor is benign or malignant. Benign or malignant. So 3 parts. When we take the data and try to execute it using quantum way, data is stored in qubits. Data is stored in qubits. Okay. And then within quantum computing, there is a concept called as trainable knobs. Trainable knobs. What this trainable knob does is, when the machine learning model is executed, it will take the different options available in algorithm and it will start experimenting with those. And finally, you get an answer, prediction result. So let's try out this part, yeah. So I'll run this. We are just preparing the data for qubits. Now, if I were to run this, we are building the quantum model. Quantum model is defined. Don't worry too much about the code. I don't want to confuse you guys with the code, right? My job is only to give you the difference between traditional machine learning model and quantum, traditional way of building machine learning models and quantum way of building machine learning models. Which one is better? And what is this quantum computing? People are saying it is super fast. It's very, very fast, and the normal computers probably cannot handle that speed. That is a kind of speed at which quantum computing works. So let's understand whether it works that way or not. So if it were to train the model, oh, it is taking a lot of time. If you observe here, and it took 8.4 seconds. And the accuracy is probably the highest is 93.5. Whereas, okay, if you were to take the new data, then accuracy is say 93%. Okay. I'll then deploy this model that we built. Okay. And for the new patient, it is telling malignant. Okay, good. So both the regular way and the quantum way is giving the right classification that tumor is malignant. Good. However, if you look at this, regular way has achieved more accuracy and it trained the model at a faster speed. Regular way. And the quantum way, when we tried out, it is giving less accuracy and it is taking more time. Then my question to you all is, why is it that the world is spending this amount of money on quantum computing? Why? Anyone? Any guesses? Why is it that the world is spending these many crores of rupees if things are that bad? Anyone? Vamshi is saying it's still in developmental phase. Okay, sure. Point taken. Any other points? Anyone? Pankaj says due to security. Narendra says security. Okay, you're saying it's very secure. It is going to develop in the future, is what Shanmugam says. Good. Anybody else? Okay. So let me see if I can answer this. First of all, quantum computing is not built for small data sets. It's not built for small data sets. Okay. So the regular way wins today. The regular way of building your machine learning models, it is faster, more accurate, right? It can analyze your complete data. You can run it on your regular computers also. Okay. Then, why does quantum machine learning matter then? As quantum hardware grows, certain problems that overwhelm the normal computers, meaning when you take normal computer and say you want to take different molecules. When we have fever, we take paracetamol. We just take that medicine. But that medicine or drug is, you know, is manufactured or we all are able to consume that after a lot of experiments. It takes 5 years to 15 years to come up with a stable compound, which can then become a drug which can be sold in the market. So those many years of experiments have to be performed. And if you have a very large optimization problems like Amazon, right? How many shipments Amazon does on a daily basis? How many shipments Amazon does on daily basis, right? If I were to ask this question, come up. Yeah. 20 to 25 million packages are shipped daily under normal operation. 8.4 billion shipments per annum. This is huge. This is large. In those kind of scenarios, if you want to understand what is the most optimized way of shipping all these items across the globe. A few people might purchase items from China, a few people might purchase items from Europe, a few people might purchase items from US, from India, across, right? So all these shipments using trucks, using flights, using two-wheelers, etc., they have to be delivered to the households, people who have placed the order. In such scenarios, when data is very large, we typically use, I mean, you cannot use your regular way. Okay, you cannot use your regular way. If you use your regular way, it will take years and years for, say, a molecule or a drug or a medicine to be released in the market, or for such large optimization problems to be solved. It will take years together. So the key takeaway is not to tell you that quantum is better today. Still, your regular way is better if at all you have smaller data sets. But if you have data sets which are very, very large, which your regular computers are finding it difficult to handle, that is when quantum computing comes into picture, right? So you might be feeling this, right? The regular model is fine. It is faster, giving better results. I can run it anywhere. But for quantum, I need specific hardware and, different way of computing and all of that. Yeah, don't worry. If the problem is very small and easy, please don't try to solve it using quantum. You don't want to kill a mosquito with a revolver. You don't need a gun to kill mosquito. Yeah. So when you have smaller data sets, etc., go with still the regular way. But quantum computing is extremely useful whenever you have large problems. Okay, here I'll show you a small thing pertaining to quantum. So if I were to run this and then explain this, even if you take in physics, there's a concept called as atom, right? There are only about 10 raised to the power 80 atoms in the whole universe. However, if you want to simulate and look at the interaction of all these, then that interaction will go beyond a point. And if you use your regular computers, even the most powerful of the regular computer can reach only 10 raised to the power 17. 10 raised to the power 17. Only that amount of data your powerful of the computers can handle. Whereas in the universe, we have 10 raised to the power 80 almost, right? 10 raised to the power 80 atoms. To process all of those and to look at the simulation of all these particles, your regular computers will not work. Okay, even the supercomputer cannot. I'm just talking about 10 raised to the power 80 atoms. That's it. That amount of data, your regular computers will fail. Hence, whenever you have large data sets and very complex interaction and simulation kind of scenarios, such as designing medicines and materials, looking at large optimization problems, okay, or learning from data that is itself a quantum. These are the scenarios where quantum computing is still valid, right? And if you look at this, in 2026, Google reported that their quantum algorithm was 13,000 times faster than their supercomputer. Okay, then ion answers, these are the companies that ran medical device simulation on a quantum machine. 12 times they were faster. So a lot of research is being done. Billions are being invested. to solve problems which the world did not solve until now, or the world is finding very difficult to solve. But honestly speaking, quantum computing is years away from us. And on tiny data sets like the problem that we solved, tumor, you will not be able to get good results. But future is looking bright in this space. Okay. Now, let me show you one more simple thing. A pattern that the regular model cannot learn. Right? Just let me do that quick comparison. We'll take the same, slightly different data set. Right? If I were to run it, look at how the data is looking. There is an inner ring and there is an outer ring, inner circle and outer circle. Okay. Say this is a kind of data set which is available with you. The way I've shown the tumor data. Red means malignant, blue means benign. In that way, say we have this data where you have inner ring and you have outer ring. So now, if you use a regular model, like say logistic regression, then accuracy is only how much? 28%. The model is just 28% accurate. But if I were to take the quantum route, quantum computing route, it's going to take a while, but the accuracy is 91%. What does that mean? When you have very complex scenarios, okay, and in the places where your regular computers don't work, regular algorithms don't work, traditional algorithms don't work. In those kind of scenarios, if you use quantum computing, accuracies can be higher, even on small data sets. So does it make sense to do these experiments? Absolutely. Okay. You can try the regular, on the regular data set also, you can try quantum way of building the models. So when next time people talk about quantum computing, you now know that on regular business problems and on small data sets or regular data sets, you will not find any benefit if you use quantum computing. However, if you have very complicated data, A. B, if you have data which requires, immense amount of computations, immense amount of simulations, in that scenario also, your regular way will not work, quantum computing way will work. So these are going to be the two key takeaways based on, all this. So for example, look at this. You have an inner circle, red color, and you have outer circle, blue color. Say you want to build a machine learning algorithm to segregate the inner circle from the outer circle. And if you try out your regular models, then accuracy is only 28%. Look at how it is classifying the data. You see that line, and everything which is on top belongs to one class, everything which is at the bottom belongs to another class. But the moment you switch from regular to quantum, accuracy improved. And look at this orange color, outline. Anything which falls inside is red. Of course, there are misclassifications. But when such typical complex patterns appear, you can still resort to quantum way. So, the regular linear model failed in complex scenario. It can only draw a straight line like this. So, it cannot look into the inner circle, right? Whereas when it comes to the quantum model learns the circular patterns also. This is one learning. Okay. So the quantum model wins here. And to be honest, if you apply, say, classical neural network algorithm, it will give even better accuracy on this. So that goes back to another discussion. If I have very complex patterns and if I have a small data set, should I still go with quantum or should I go with deep learning algorithms? My answer is go with deep learning algorithms when you have small data sets and complex data sets. Okay. If I were to just bind it up with a specific write-up for you all, then I would say if we have small or regular data sets and if the patterns are simple, then use regular models. Okay. However, oh, sorry. Okay. Then, if we have small or regular data sets, and if patterns are complicated, then use deep learning models. Deep learning is a specialized branch of machine learning. Okay. And the third scenario is if we have large data sets and if the patterns are complicated, use machine learning models using quantum wave. Okay. You can use the regular way or the quantum way. However, when should I use what? That's the key. So if you have small and regular data sets, and if the patterns are simple, use the regular machine learning models using your regular way. If you have small and regular data sets, and if the patterns are complicated, use the deep learning models using, again, the regular way. If you have large data sets and if the patterns are complicated, use machine learning models using quantum way. This is the principle as of today. But future looks very bright. Okay. Especially if you're going to work in scenarios where there are too many complicated things to be taken care of. Maybe stock market trading, maybe in the space of physics, maybe in the space of drug discovery. In these kind of scenarios, yes, quantum computing will be the future. Thank you so much. And this is all I wanted to explain as part of today's discussion. And let me, Giriraj, Girija is asking a question. How do we even determine if the pattern is simple or complex? That's what your question is. This answer you will get by doing exploration on the data set, Girija. It's not simple. For example, for me, if you have far too many variables, for example, in your data set, let me take an example of power trading, right, Girija? For GMR, we are doing power trading. GMR power trading. Here, we need to predict or forecast what will be the price of power. They purchase power and sell power, GMR power trading. What should be the price, or what will be the price tomorrow, day after tomorrow, 3 days, 4 days from now, is what they want to know. Okay. Now here, can someone tell me what are the different aspects which should be considered? What are the different aspects which will impact the power of price? Anyone? Anyone? What do you think, friends? Anybody? Because power is generated using solar, wind. It is generated using renewable and non-renewable sources. Okay. And amount of coal mining that happens depends on what? Consumer price index, producer price index, right? Government regulations. If government is relaxed and it is supporting industrial growth, then a lot of industries will come up. It depends on the temperature, it depends on humidity, it depends on the wind direction, it depends on the cloud formation, it depends on multiple aspects. Whether there is IPL match going on or not, that also matters. Whether it is summer, rainy, winter season in different parts of the country, it is summer somewhere it might be cold as well in India. It's such a large nation. So there are multiple factors which come in. And we have very large data set here. Then what do you think? Do you think the regular patterns or regular way of building the models will be helpful, or do you think it's very complicated just by the thought of it, right, Girija? Just by the thought of it, it's becoming very complicated. Too many variables which fluctuate a lot. So automatically, you know now, based on your domain knowledge, based on your research, that the data is going to be very complicated. In such scenarios, you know what technique to be applied? Quantum computing is not that prevalent today. Otherwise, probably for these kind of problems, quantum way would be the best way. Okay. Okay. So yes, Banu, yes, Sharanya, it depends on transmission, distribution cost, location, tags, temperature, wind, humidity, right, Anant Kumar? Demand and supply, Girish, absolutely. Mohan is telling Discom, distribution companies, power distribution companies, contracts, yes. Sanjay says power consumption also matters, absolutely. Then Feroz has a question. Why is it taking less time for complex problems and more time for simple computation? Did it take it that did it happen that way? Are you talking about quantum? See, quantum does an additional calculation under the hood. There are a lot of quantum computing algorithms, right? Which does initially some extra computation so that the next set of computation becomes simple. Okay. But if it's a very small problem which can be resolved just like that, you're putting that additional effort to make it simple, then do the calculation. So that's why it will take more. But it's a different and bigger subject to be discussed for us. Yeah, it's a different hardware, I should say, Vamshi. But then there are algorithms. It's not just hardware, right, Vamshi? Quantum computing is not only related to hardware. It's related to the software and the algorithms that run inside also. And we just, try to understand the software elements and the algorithm elements, as part of the code that we run. Yes, Manjeet. Wonderful. Pankaj says, I'm currently data analyst and would transition to data science. Could you please guide me on the best approach? Practicals, my dear friend, Pankaj. Focus majorly on the practicals. Okay. That's the one thing that's going to help you. It's practicals, practicals, and practicals. That's going to help you immensely. Okay. Not just theory. All right, friends. Thank you so much. I think Payal is here to take her session. Do you have session, Payal? Not sure, but get started. Yeah, we'll talk offline, Jake. Yeah, we'll talk offline. All right. Thank you all.